1. Now, what is the 0? The 0 is the foreground, is the part of the image that we want the unit model to focus on. Like I gave the example earlier, a cat. The cat is the foreground. The sitting room, the chairs, the children in the background, the tiles, the TV, everything at the background. And we don't want the model to learn any of those. We only want it to recognize or segment the cat from the remaining things in the background. So the mask that I showed us earlier, like I said, each of these nuclei or nucleuses, or nuclei, are the foreground, and this black place is the background. So the foreground are labeled as 0, and the backgrounds are labeled as 1. So this is the kind of structure that your data set will need for pre-processing, and so the model can understand what it's running with. But it's more complex than this. The code is actually, this is just to restructure the code to this, but you still need to further define a custom data set for the unit to run. If I go into that in detail, we might not finish this presentation, but I'm just explaining my processes. So if we notice this image 0A7E is the original image, but it also has its masks. That's the foreground and background of the image. So this is what the model needs for image segmentation. And in summary, that's what this pre-processing is trying to do. It creates new folders where it stores the masks, the zeros and the ones, and all that. It defines the image size. It divides. So let me know. It creates folder names and all that and all that. So the end product is that this becomes this. So it does that. Now let's just move on. Dataset.py is the next script we'll need to run. Datasets.py. Right. So in summary, dataset.py is where you define a custom dataset class for the PyTorch to use. PyTorch expects a particular type of data set which it can use to feed the unit model with images and with the training masks and with the masks rather. So that's what this script does. The script only works with a data set that is this structure. Remember, that's what this former code did. Preprocessing. It's created the image and the mask structure. So that's what this dataset class will work with. Right. So if you are using another, I'll say this, if you are using another, you don't need to change the code. If you are using another data set that has one image and one mask, this is still okay. Just make sure it's structured this way, that in the image folder, that's here, in the image folder, it has all the images. Then there's also a mask folder. And in that mask folder, there's a 0 folder. And that 0 folder will contain these images, the masks of the images. That's the foreground, and then the background of the images. So if you explore the code, you know how to implement it for other data sets. And although I must say that doing that could be quite tedious, but there are a lot that's online that come with their codes. So you don't need to stress yourself trying to type all this code and structure everything, and all that. Like this one, I got it from a repository, so I don't have to stress myself too much about, okay, how am I going to write the code to structure all this? You can research on the particular kind of data set you're working on and find out how they are um, using code. On GitHub, you can check research gates and all that, to find out what kind of code they are using to get the data set ready for the Unit++ model. So this datasets.py, it initializes a list of image identifiers. It initializes the directory containing the masks files, um, the of the image. I mean, the dimensions of the image. That's another thing you need to consider. The dimension. Okay. Oh, so sorry. Was been um. So, but where did you stop hearing me? Is it better now? Okay.
I
All right.
think he is
Sorry.
talking now.
Okay. Okay. So sorry. Um. Yeah, it's my network because of this is even um disconnecting. All right. So one other. Okay. Questions. Okay. Or can I take them at the end? Okay, so I could maybe I'll answer some of those questions in the course of teaching. Okay, so um, one thing we have to do is realize is that we need to reorder the dimensions of our images properly so that it brings the channels first, the number of channels, then the height, then the width, which is usually 64 by 64, 128 by 128, and all that. So
I don't think I can hear him. If any one
you
of you
know,
can hear him,
oh, you can't hear me. Oh, okay. How do I do this? Can you hear me now? Okay, it's my network. So sorry about that. But where did you stop hearing me? Okay, so you can just check it out in this datasets .py dataset.py. The code, um, and I've explained it, I've documented what the code does in the repository. So one thing you must know is that the channel comes first, then the height, then the width of your image. And it's also advisable to use an image height and width, an image size that is divisible by 2, because like I showed earlier, your down pulling, you taking it through the encoder would basically halve the size of the image. And if your image is something like 133 by 133, it would have serious issues because you cannot divide 133 by 2. So it's better it's something like 64, 128, 256. Yeah, so by 256. Okay, so the next script is the metrics. Now, this metrics contain two functions, which we will load later on. Basically, it contains the IOU score function and the dice coefficient. And these are very important in evaluating the performance. Can you still hear me? Okay, because it's reloading here. In evaluating the performance of your model, these are very important. Dismiss. So this is the IOU score. So what it does is that it calculates the intersection. Sorry. It calculates the intersection over union. Now, this is something, intersection over union is what is used to check how close the image is to the predicted image is to the masks or the ground truth. So the intersection just basically shows what does that intersection show again? It shows how much it's overlapping with the ground truth. You can do some further research on that, how much it's overlapping with the ground truth. So it shows that difference and okay, it makes adjustments. And the union shows how much of the target area or the foreground area is covered by the outputs of the image segmentation model. So that's, sorry, it's trying to reconnect. My network is not so good. All right. And then we have the dice coefficient. So these are basically used for evaluating the performance of the model through its outputs. Then we have the next script that you would run is the losses. You want to calculate the binary cross entropy loss. Okay, where is it? You want to calculate the binary